So let's continue with the last lab and last question. Question C. Set Vs equal to 30 millivolt V peak to peak and remove the 470 microfarad bypass capacitor CE. Measure the output waveform and calculate the voltage gain AV. The V output I get is a 0.7 volt. And I already disconnected the CE from the circuit, and the V sign I set up a 15 millivolt for amplitude V peak. So that's right. And the output became like this. This is because the voltage gain with bypass capacitor is higher than without bypass capacitor. This is because when AC analysis the capacitor will be short circuit. So when we connected the capacitor with RE, the RE will be short circuit or will not be function. Thus, there is no voltage drop happen at RE. Therefore, the output voltage will be maximum voltage. That's why the output will be high. So when the capacitor is disconnected with RE, the RE will be function. Thus, there will be a voltage drop at RE and the output voltage will be minimum. So as we can see here, the output is 0.7 volt. And let's try with the capacitor. Yeah, the voltage start to be smaller. If you can use like 500 milli 10 millis, you can see it's very high. But when we use without capacitor, you can see that 10 millivolt is not very high than the 10 millivolt we so we can see that 10 millivolt with capacitor is very high, but we are open. So but without capacitor, the 10 millivolt is not very high like the previous one. Okay, so that's all for me. Thank you. So let's continue to the part 1, DC analysis of a common emitter amplifier. Construct the circuit and use a DC emitter to measure the current IB. Be sure to connect the transistor in the proper orientation. So the IB that I got is a 51.8 microampere in Proteus. So the second one is to measure the DC bias voltage and the current throughout the circuit and record the reading table. So the VCC is a 15 volt. And my VB is a 1.55. And the VE 807 milliohm VE, and the VC is a 15 volt. The VBE is a 0.74 like this, and the VCE is a 6.25 volt. And the IB is a 51.7 microampere. IC 11 milliampere. IC 11.7 milliampere. And the IE is 11.9 milliampere. IE 11.9 milliampere. So let's continue to the part 2, essay analysis of a common emitter amplifier. We'll modify the circuit in figure 4 as the one shown in figure 5 below. Apply a small 30 millivolt peak-to-peak sinusoidal input at 5 kHz using signal generator. Connect the oscilloscope to the circuit to observe the input Vs and output signal Vo. Make a sketch of this voltage and calculate the voltage gain AV. Let's try. So I have set up a 15 millivolt for amplitude, because 30 millivolt peak to peak have to divide it by 2 in order to get 15 millivolt at the V peak only. So the frequency I use is a 5 kilohertz. So it's a frequency of 5 kilohertz here. So strength. And the result I got like this, and my voltage divider is a 5 millivolt here, and my V out peak to peak is a 1 volt here, and the blue wave, sine wave, is the output voltage, and the yellow sine wave is a input voltage, and I use a 5 millivolt for each box here for sine wave, yellow sine wave, and 1 volt for blue sine wave. And the result I got is a expected result should have, because the our V in and V output has a difference in 180 degree phase shift. So the V in is here down, and the V output is from here, and the V output also will be high because due to the amplifier. So let's continue for the question B. With the oscilloscope set at AC, increase the input signal amplitude Vs until clipping is observed. Then reduce the input until the maximum output voltage that contain no sign of clipping is found. Record the peak-to-peak values of both the input and output voltage. So this the result of non-clipping, and the clipping we show in photos. So first of all, I set up a 30 millivolt for V peak. So let's try, and there is no clipping yet. Let's try with 31. Also, there's no clipping yet. Let's try 32. You start to see a little bit clipping here. And let's try to 33 milli. And they start to clipping a little bit. Let's try 35. and there is a clipping. So the V output peak to peak is a 1 volt, and the V in peak to peak is a 16 millivolt, which is a 30 millivolt for V peak. The first one I used, and there is no clipping when I use that. So the clipping is happen because when the voltage is too high, when the voltage input is too high, or the bypass capacitor is connected parallel with the emitter resistance here, the R4. Okay. Assalamualaikum. My name is Muhammad Iqbal Bashir Masarwi. My number matrix is AA191616 from section 1 electronic. Today I will present a lab for electronic experiment number 4. The experiment title is common emitter amplifier. So the prepared calculate the theoretical values for the voltage and current in the circuit in figure 4 and record them in a table similar to table 1. Assume beta equal to 150. So these are my calculation. I got the RTH is a 1.07 kilo ohm, and the VTH is a 1.61 volt, and the input voltage, the current for IB, I got 80.26 microampere, and the IC, I got 12 milliampere, and it's quite similar with IE. And the VCE, I got 6 volt, and the VC, I got 13.64 volt, and the VE, I got 816 millivolt, and the VB is 1.52